Welcome to problem set 4, everybody. It's March. That means we're going to be focusing on basketball data for the next couple weeks as we move into tournament time. So with problem set 4, you're going to be giving 2 teams worth of data. And you're going to write some algorithms to process them. This is what the user interface for problem set 4 looks like. Your TA team did an amazing job putting this together for us. This is way more beautiful than any problem set that's ever been used in Comp 110 before. So let me just explain a few things for you. You've got your away team on the left, your home team on the right. You can change the teams that you're going to be analyzing data for to test out your algorithms. And when you click this button, Run Match, you're going to see a table pop up with the analysis that's been performed. And here we're just using the starter code that we were provided with, where we have just the number of wins each team has as a single score line on our scorecard. And what's happening here is, you can't really tell, but we're summing up all of the values on the away side to make the total score for the away team, all the values on the home side for the home team, and that will pick the winner, whichever team has the higher value, or if there's a tie, we assume that the home team wins. All right, so we can change teams and try running different analysis. It turns out Baylor's won as many as Duke, Boston College is really struggling, so on and so forth. Just to give you a little sense of the other pieces of this interface, there's this Get Stats button, which is going to be really important when you get to working on your own statistics to think about, to sort of browse what's available to you. And this gives us our team level stats, and not just the value for each of these stat lines, but also the rank across Division 1. And then we've got our roster here, but if you click Detailed Player Stats button, you'll get a pop-up with all of the detailed stats that the NCAA website provides, and your TA team did an awesome job scraping this for us so that we didn't have to get all this data ourselves. And we can see we've got our players, years, positions, heights, free throw percentage. If you click on one of these labels, you can sort by it. If you hover over it, this is really important, you'll see the method call that you would have to make on a player instance in order to get this data. So here, if you said some player dot get free throw percent and use that method call, that would give you back this data. And we'll see that on the website down at the bottom, all the way at the bottom, we've got all of the methods available to you for both teams and players that you can call in order to get the data you need. As you're working through this, we provide the methods that you're going to need to use for each part in line. But when you get to writing your own algorithms for the bracket, you'll be using this a little bit more intensely. So that's the user interface we're working with. There's also a little chart that's kind of cool that you can compare visually where teams are performing well or poorly based on the analyses that you're running. So let's look at what's going on here. So this is the method this is the class that we start you out with. It's a class named Tar Heel Tradition Algorithm. And there are no instance variables. The constructor does nothing. The only important method is this one here, the score method. And score has 2 parameters, 2 inputs, 2 extra pieces of information it's given, an away team and a home team. And from these 2 inputs, from these 2 teams, we're going to generate as an output a scorecard that gives each of them a number of what we're calling score lines, or this is for example, this example wins line is a score line that get added up to give them a total score. All right. So let's just play around with this for a bit. Like if I were to change this label here, so a score line has 3 parts to it: a label, an away team value, and a home team value. So if I change that label, got rid of the example wins, we'll see that the next time I run this, that label is just wins. If I wanted to play around with this, I could go ahead and add a second score line. And notice that what's happening here is we're setting up a label, we're setting up a double to hold our away value, a double to hold our home value, and then we're setting up a score line instance called example, constructing a new score line, and the constructor for score line takes 3 pieces of information. These are the 3 arguments that we're giving it. We're giving it a label, we're giving it an away value, and a home value. And remember, from what we've learned so far, we could just substitute these with hard-coded values. So if I did something like scorecard.add new score line and called the constructor straight away, I could say something like hard-coded, and we're playing against a random away team, so we could just give like -10 points to the random away team and 10 points to our home team, the Tar Heels. And when we run this, we'll see here's that hard-coded line that was just added. The Tar Heels got 10 more points, and Miami got negative 10 points. And you'll see that we're just simply, to come up with the away team score and the home team score, we're summing each of the values for each of these score lines, right? And so if we change these two teams, we would get different results. So we could do Georgia Tech versus Indiana, and you see that these are different results as well. Just to talk a little bit about what's going on with these two team parameters that we're getting, you can see here that when we calculate the wins score line, we're using away.getwins and home.getwins. If we wanted to add a score line for losses, say, and this isn't one that you'll have to add, but we could try it here just to demonstrate. We could do something like score line losses is a new score line, and the label will be losses, and the away value is going to be away team dot get losses. And we'll multiply this by -1 because losses should count against you, let's just say, and home dot get losses times -1.0 as well. All right, so I save this, Eclipse auto formats. Now I need to be sure that I add that score line that I just set up to the scorecard, like we did with wins and the hard-coded value. So we say scorecard.add losses. All right. So now when we run this, we're going to see a new score line shows up on our report. Here it is for losses, and we see that Carolina has 5 losses and Oregon has 6. These statistics are current as of like 2 days ago, so the fresh pain of UVA is not quite stinging as hard yet. And so your task then is to add a number of different score lines from, in part 1 of this assignment, right? And so we've prescribed some for you. Like here, we're going to take a look at Kendall Marshall, who was graded assists, and we're going to look at assist turnover ratio as one score line factor, whose label is going to be K Butter. And so each of the score lines has a requirements section, and the requirements give you the specific label you need to use. You should probably just copy paste what's between the values here, or the quotations here. You should use the label exactly for part 1 of this assignment. And then here, the values, we give you what you need to use. You need to use the assist turnover ratio multiplied by 10. And then we tell you down here that the team methods that you're going to use are get assist turnover ratio. And you can see that for an example input of the data that we're providing to you in this problem set, Duke would have scored 13 and UNC would have scored 17.1. We do the same thing for all of these score lines, and there are 10 of them for you to implement. They start out very simple. So this one's super simple, assist turnover multiplied by 10. And by the time we get down to like number 10, they're a little bit more tricky. So Real Blue Steel, we're talking about our walk-on team. And so the Real Blue Steel score line is calculated by saying the sum of the points scored by players who averaged less than 2 minutes per game. And so you're going to have to write a loop, and you're going to have to loop over the players on a team. You can ask a team for its players by calling the get roster method, and this will return to you an array list of players. Then you're going to write a loop that handles a little bit of logic and does some calculations in that way. So expect these to take a little bit longer once you get started, but I think the first few should go very quickly. And then once you get to the ones like 7, 8, 9, and 10, they'll take a little bit longer. When you're done with part 1, part 2 is doing something very similar to what you did in part 1, but you're going to invent your own set of 5 different score lines that you want to add to your own custom analysis. And we're going to take this algorithm and use it to power your bracket. When you get to part 2, all you need to do is go to your runner, change the algorithm to a new instance of your bracket challenge algo. And you can start working on your bracket challenge algo, which has exactly the same format and setup as the Tar Heel tradition, but hopefully you'll use some better ideas that will make you more competitive in the class-wide March Madness bracket we'll be hosting starting over spring break and through the entirety of the NCAA tournament. This is problem set 4. I think it's going to be a lot of fun. The TAs and I have put a lot of work into getting this ready for you, and so enjoy it. look forward to seeing what algorithms you come up with for this year's bracket challenge. Any questions or problems you have, feel free to ask on Piazza, and know that you can come by office hours anytime.